Hello and welcome back to Elementary Algebra section 3.5 Slope-Intercept Form of the line to complete the title. So the book is just says Slope-Intercept Form and its name, right, will tell us very easy to remember what the formula looks like for the line. All right, so what is the focus of chapter 3? Linear, which means straight, line. And we learned already one form of that line. That was ax plus by equals c. In some cases, that one is called standard form. Sometimes it's called standard form, sometimes it's called just linear line, sometimes it's called, what else? So standard form, linear line, or formula with two, right? Equation with two variables. But most of the people will call it standard form for the linear line. Today we are learning slope-intercept form, and that's probably, you know it, y equal mx plus b. So it's called slope-intercept form because it has slope and y-intercept displayed, ready to just read those numbers without any calculation. So slope-intercept form, and the name is because the slope and the intercept are in the equation. They are displayed for us to read without any calculations, and we can just use it very, very quickly. So in mathematics, if we are supposed to graph a linear line, it's the fastest method possible. If you studied at all, you learned that standard form was graphed through x and y intercept when you use that chart that I presented last time with 0, 0, and then you use that to graph. And you had to do two computations, right, to figure out these two numbers that are missing. But now, with the slope-intercept form, the only thing you need to do is counting. And that is way easier than doing any computation. I hope it is easier. So let's take a look at the power of slope-intercept formula or form. So let's say we have this coordinate system, x, y, and we want to graph y equals 3/2 x minus 1. If you want to graph this slope-intercept form, it is very simple because your y-intercept is displayed, that's that b part, and you can quickly graph that point on the coordinate system. So whatever value you see as b, that is going to be on the y-axis because b is the y-intercept. We remember that the y-intercept is 0, y, right? So, well, b, but it's a y value. So in my case, b is -1, so I graph point -1. And now we take a look at that slope we studied last time, and we are going to rename slope a little bit. Well, we're not going to rename the slope. We're going to look at the way we count the slope, and we're going to call this fraction rise over run because that's going to help us a lot. So for the slope, we're going to say rise over run, and that is going to help us a lot as we graph these things. So I see that I need to rise 3 units up. So 1, 2, 3, and then run 2 units, which would land me here at 2, 2. And all I need to do is to draw this line through the 2 points. So all you need to draw a line are 2 points. One is always displayed, which is the y-intercept, and the other one you obtain by counting the slope starting at whatever your b value is. And believe it or not, that's it. This is how simple it gets now with graphing straight lines, the linear lines.
Could you just explain that again? Because like I lost like complete internet, so like I could not hear you that entire time.
Yeah, we're going to do more examples, but
Okay.
the whole procedure is always going to be the same. So, what is the procedure? We have to write that one down. So, procedure is, number one, we graph y-intercept, which is 0b, and that's always visible in our equation. We have nothing to think about there or understand. It is a value that it's always given in the formula, and we always see it. Whatever you see is what gets graphed on the y-axis. Then we count the slope starting at b using rise over run. If you end up with a whole number here, you just put that over 1, make it a fraction, and you have rise over run, and you can just count. And finally, 3 is draw the line. Maybe I should add the step 4. Win. There you go. Done. So that is our procedure. You graph the b value first, which is your y-intercept, and clearly because it's a y-intercept, you graph it on the y-axis. So whatever number it is, you graph it. And then starting at that location, you go and count the slope that it's given to you. All right, so let's take a look at a couple of more examples of the same procedure, same thing. Here we go. Why have you blue? Okay. So we have our x and y, and the equation we want to graph is y equals, let's say, 2/5 x plus 2. Or let's do 3, so we have all numbers different. So 2/5 x plus 3. As I said, step number 1 is always you have the y-intercept clearly visible. So 1, 2, 3 is our start point. Then your job is to start at that point and count the slope. Now the slope is rise, which means rise 2 units, and then run 5 units. Now you run to the right, 2, 3, 4, 5. This location over here is 5, 5, because we have 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5 on the top. You connect these 2 points with a straight line. That line missed. Let's call this good. And you're done. It takes very little effort to graph these lines. Now, full credit for these questions on exams, including the final, is to write down x and y and write down the coordinates of the points, and then obviously to have the correct line and all of that stuff. But usually students lose points because they do not label axes. So depending on the exam, depending on the problem and so on, just labeling x and a y gives you either a point or 2 points. Labeling each one of these separately is a point. And then the line itself, right, is going to be 2 points. So you can lose more points for not writing coordinates and axes than actually doing the problem correctly. So please make sure you do that. So one more time. First thing we do is whatever we see there, we immediately, whatever we see, we graph on the y-axis. And then we start there and we count, in this case, 2 rise 2, which is 2 up. And that gets me from 3 to 5. And then run, and run is always going to the right. Run 5, so we count 5 and we're done. Another example. Y equals -3/5 x plus 1, whatever. What do you think? How's this problem going to be different or the same as previous ones?
It's going to be like a downward line, so negative.
Excellent. It's a negative slope. It's a negative slope because of the minus, so the line has to look like that. Very good, very good. And in this case, you have a rise of -3. Well, if you have a rise of -3, that means 3 down, right? Rise and then negate the rise, which means fall or drop or, go down. So when you negate rise, you get go down. So we're going to go down 3 units and then 5 over. But we first have to start at 1. That's our y-intercept. We start at 1. And then we count 3 units down. 1, 2, 3 units. And then 5 over. 1, 2, 3, 4, 5. Make sure that when you are counting, you count the origin as well, because that is 1 unit to get to origin, and then another unit to get here, and then finally the third unit to get where our -2 actually is. And then you run 5 units forward, which makes this point over here 5 for x and -2 for y. The only thing you need to do now, well, label x and y if you want full credit, otherwise don't worry about it, right? And now all you do is you connect these 2 points with the straight line, and that's it. You're done. So there's the straight line through the 2 points. You can put these arrows at the end, signifying that this line will go forever in those 2 directions, and your graph is done.
So are we going to have like anything more complicated than this where like you have to solve like an equation to get this to graph it? Does that make sense?
Well, you will see what's coming up, chapter 4, obviously, and so on. But this is the last section for chapter 3.
And that's pretty much it. It's just
I hope you're not disappointed, but yeah, that's it.
No, it's fine. It's fine. This is more than enough. We're good.
So let's take a look at the flip side of this, remember we had 3x minus, let's say, 4y is equal to 12. So again, graph, right? Graph this. So now this problem is not given in the y-intercept form. It's a standard form, but you know how to graph this problem because you know that this problem is in a standard form, and you can quickly come up with x and y intercepts, which you can graph on your coordinate system to get the line. So let's put the coordinate system here, let's say, and your job is to graph this equation. So we have our y, we have our x, and then now if we are trying to graph this, we are populating the x and y intercept chart, which is what we studied last class or two classes ago, right? Because it was in 3.3. Yeah, okay. Now we remember to find the intercepts, all we need to do is to find the y-intercept, right? We plug 0 in our problem. So again, this is a 3.3 calculation, and now we're just using it to to graph the problem.
Wait, I feel a little lost. Is it always going to be like the way you just set up the x and y? Is it always going to be a 0 and a 0 underneath it like that?
Yes.
Okay.
That was in 3.3. It's not going to change, and we're going to use the same in chapter 4. So for standard form, you always have your intercepts as the fastest way to graph. For the y equal mx plus b form, you have the procedure where you graph b and then go with the slope. So those are the two. All right, so now we have negative 4y equals 12. Divide both sides by negative 4. And we get y equals negative 3. So we have our negative 3 value, and we can put that negative 3 immediately on the graph because that's the y-intercept. Then go again. Now this time y is 0 for the x-intercept row. So when y is 0, we have 3x minus 4 times 0 equals 12. That's just 3x equals 12. Divide both sides by 3. X equals 4. So now that's going to be a 4 over here. And then we have 1, 2, 3, 4, which is there. So in this case, we have to compute. When you have the standard form, you have to compute. But when you have the slope-intercept form, you can just count. So here is our straight line going through these 2 points, and the problem is solved. We have the coordinates labeled, we have axis labeled, the line is going through the points. So this is what would 100% right solution look like if you have everything there. So those are the 2 methods to graph the equation of the line. And again, we do this so that we can make quick decisions by looking at the graph, because we know that the positive slopes rise to the right visually. We know that whatever concept we are observing is growing in its value. And I mentioned population last time, but we can take a look also, let's say, vintage car versus just a regular car, right? For the vintage car, if the is linear in terms of value, vintage car you pay for some amount, and then the older the car is, the more it costs. So x-axis is going to be time in years, and your y-axis is going to be money. So you can see that the value of the car of some, whatever it makes them special. I never understood why some cars more special than the other in terms of the vintage stuff, because any current car is going to be way more comfortable and drive much faster and smoother and everything else. So I don't understand the vintage car thing, but again, you know, some people do and like it, so I let them have their fun. The vintage car thing is, again, right? The older the car is, the more expensive it is, right? There is a condition and all that kind of stuff. Now, if you have a regular, you know, everyday car, I don't care, you know, what type of the car, and you still have the situation where you're looking at the money in, you know, a number of years, you can see car depreciate in value. So you maybe paid 30K for it, and then you wait, I don't know, 13 years or whatever, and the car is completely worthless. You can't even get like $100 for it. You have to pay for someone to tow it away from your house because it reached that zero. That's actually negative, right? You'd be at the position right there, right, where you have to pay for the car to be towed away from your possession. So this is the reason why we do graphing in mathematics. We do graphing in mathematics because we want to um, have a quick visual cue to where the values are growing or the values are diminishing. Now, this could be population, could be money, could be, you know, ecological problems. It doesn't matter what you are observing. When the line goes up to the right, its slope is positive, and when the line drops as you go to the right, then the value is diminishing and you are losing, whether it's population, money, whatever it is, the value is diminishing. So, and now to graph these lines, obviously, we learned two methods in algebra. We learned the method for these standard form, which is the first line we learned, first form for the linear line we learned, and then we also learned the procedure for y equals mx plus b, which is called the slope-intercept form, because this is the fastest and easiest way, because it doesn't include any calculations. You just count and you draw the line. So that's the graphing part of this. We are going to graph a couple of problems just because, right, we can, but we need to focus on equations now, which are the part of this lesson as well. So how do you come up with these applications and lines and so on? So if you are to try and figure out equation so that you can predict the future, which is why mathematics cannot be avoided in any aspect of our life. It's the only thing that accurately predicts the future if you have the facts straight. So you know, strip away all of the opinions and feelings and all of that nonsense, and you just focus on the measurable data. In that case, you can develop mathematical model which will accurately predict the future, which is why mathematics is always in the center of everything. If you say economics or business or it's just numbers, 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 and then you go to engineering, right, and you go to all of these other things, they all have very definite outcomes, and you can use it to predict the future. So that's why some people that know mathematics can with confidence talk about the future. So now, how do I come up with the equation and say that, you know, if I sit on this car for another, you know, 3 years, I can make additional $2,000 or something. So let's just wait and not sell it now, and so on. The trick is that when you, and this is how mathematics works across the board, doesn't matter which level, if you have two snapshots in time, right? If you have two snapshots in time, then you get to make an equation which can compute what would happen in the future. So if you say that you bought a vintage car, and I'm not going to go into any details, I'm just making stuff up. So if you bought a vintage car of some whatever type or whatever model, and in, let's say, 2005, right? So that's when you purchased it in 2005 at, I don't know, $20,000. I don't care. Probably 200,000, but whatever. $20,000. So some kind of vintage car. It is not obviously 2005 model. It's something from 19 blah blah blah, whatever. And you paid 20,000 for it. And then you had it appraised, let's say, you had it appraised in 2012, and the appraisal for it was, let's say, 26,500, appraised in 2012. And now you want to know how much would this car be in 2020. If you pay attention here, you actually have 2 points, 2005 and 20,000, and you have 2012 and 26,500. So you have the 2 points from which you can calculate the slope, because we learned that the slope in the last class was y2 minus y1 over x2 minus x1. So if you call this point 1 and you call this point 2, you can calculate the slope, which shows you the rate of change of the price in time. And then we can come up with the equation of the line. And I can use it to compute the future. So what am I going to do? Well, simply compute the slope by plugging these values in. Now, when you plug 26,500 and you subtract 20K, well, that's simple, right? And then you have your 2012 minus 2005. These are all simple calculations, because when you take a 20,000, it's 6,500 left. And then that will be over the period of 7 years. Now you could go and divide this and get a decimal, but we don't like decimals, right, as our slope. We like a fraction, because fraction we can understand. I know that the car is increasing in value because it's a positive slope, right? The car is increasing in value 6,500 every 7 years, because this is literally means this much money per 7 years, because that's how many years I have in the denominator. So if I have this now, I can already start my y equal mx plus b equation, because I just calculated m. It is this much. The only thing that I need to figure out now is this b, and I have everything I need to predict the future. Now, what do I say predict? What do I mean by predict the future? I can then plug any year I want into that x, and it will tell me what the value of the car will be if it continues growing at this linear pace. Was there a question? Okay. So, how do we...
My Wi-Fi is just really bad, so like I keep like going out of what you're saying.
Don't worry about it because you can watch this on YouTube at any point. So, and you can rewatch it, 15 times if you want to. So there is no reason to, to panic. See what you can see now, and then just watch it whenever you get the chance later in peace. All right, so what we are going to do now is just use our x and a y, either of the 2 points, it doesn't matter. And once we plug everything in, we will be able to calculate b. This is how we come up with equations that can predict, should I sell or should I keep the car, or how much additional money would I make if I wait for a certain time. So let's take a look at now what do we have. We have y equal mx plus b. We just calculated that m is 6,500 over 7. And we pick one of the points. We can pick the first one, doesn't matter. X is 2005 and y is 20,000. As you can see, plugging these three values into the equation will only have b as the unknown quantity, at which point we can calculate b and we will be done with the equation. So y is 20k, m is 6500 divided by 7, x is 2005 plus b. You can use the calculator if you don't want to compute these things by hand. And once we solve this, we'll have the b, and we can calculate for any year we want. Now, obviously, this is applied problem, right? This is something that shows you how people come up with these equations which predict the future. Now, we're going to obviously go and do some way easier examples with, they're not easier, they're the same example, absolutely same steps and everything. It's just the number is not 20,000, the number is 6. That's going to be, in the next example. But let's now go quickly and look at the values that we get over here. So first, by PEMDAS, right, we need to solve this. And to solve that, you can either use the calculator or whatever, because again, numbers are large numbers. So we multiply 6,500 by 2005, and then we divide that number by 7. So we get this crazy number, which is okay. So we have 20,000 equals to, when we compute all of this in a box, we get 1861785.71 plus b, and we separate this like that. And now what we do is we just subtract this number on both sides. So minus 1861785.71. If you watch this video again, hopefully it will make sense of what I am doing here when you do it at a slower pace and look at a couple of times. But again, this is a problem that is applied problem. It is not necessarily something that you must know. We are going to do the same problem now with much smaller numbers, if the numbers are what is giving you anxiety. If anyone is having anxiety looking at this, the numbers are irrelevant. It's the procedure that we are focusing on. All right. So when you do this subtraction here, by these numbers cancel. When you do the subtraction, you get negative 1,841,785.71. And here it is. Y equals 6500 over 7 times x minus 1,841,785,71. So now, if I want to see the price of the car in any year, given that it's going to keep linearly increasing like this, I can tell you the price in 100 years from now. I can tell you the price today in 2020, because if you want to know what the car is worth today, you just plug in 2020 for that x. When you do the calculation, it will give you the value of the car for the year. So now let's just recap the problem, because maybe we can even do it. So price in 2020 is y equals 6500 divided by 7 times 2020 minus 1,841,785,71. There we go. Multiplying this value, dividing by 7, and then subtracting the number will give us the price in 2020. I'm just going to, as I said, it's not a learning outcome here, so I'm just going to quickly compute the number. 785.71, and the answer is, it would cost, or the value, $33,928.58. So we can approximate the value right in the future, just because we had two points of interest before where this problem started. So I know that you can just go back and watch the whole thing from scratch, because right, it stays as a video on YouTube. But let's just quickly take a look one more time. So what I did here is I just found two pieces of data from the past. You maybe can Google this stuff, and it doesn't have to be car, it can be literally anything, given that it's this linear growth. So I have two pieces of data, and then what I did is I created points, keeping time as x and money as y. And now, when I make my points over here, I can use the slope formula from last class to calculate the value for the slope m, which goes into the equation. So the slope always tells you the change of whatever you're observing per unit of time, for instance. So in this case, what we found for this slope is that the value of the car increases 6,500 every 7 years, right? Every 7 years, the value of the car increases about 6,500. So now that we have the slope, we need to calculate the b value, and once we have b value and slope, we can put the equation together. So this is a key point where a lot of people get confused right here. Your job is to calculate b. If we go back to our equations where we did the graphing, and you look at the equation, what are the numbers given? M is given and b is given, and you can see x and y, right? So we need m as a number. Well, we already calculated that. That was that 6,500 over 7. We also need b, because that is the y-intercept. And once you have those as numbers, you have the equation where you can plug in x and compute y. In this case, you put in a year, and you come up with the money on the other end. So these equations are insanely useful. And that's why, as I said, literally everything you see and touch is based on mathematics in one way or the other, because it has numbers in its right, in its base. Now someone's gonna, how about love? How about feelings? How about, none of that stuff is real. This is real. All right, so going back to our problem, we have an equation here, and we have 1, 2, 3 numbers that we can plug into that equation. And when you plug those numbers, as you can see, the only variable is b, which is what you are looking for. And now you can, these are large numbers, so I use the calculator to solve this. And I used the calculator to solve this and came up with the value for b. Now, the numbers that you are going to see on exam are all going to be much smaller than these numbers, but your homework on MyMathLab might have numbers that are this large. If they deal with population, right? Population of the planet is over 7.5 billion now, right? So population of the United States, 335 million. Those are large numbers. So you might see some word problems with large numbers regarding these calculations. Now, then I hopefully had some success in bringing to life where these things and how these things become important, and why is mathematics, right, required to be the part of every program, even, if you don't care about it. And it's just the simple fact that it literally drives everything that we have on this planet, every concept, everything, because if it has a number associated with it in any capacity, it's going to be math. So we were able to come up with this equation, and now, as I said, you can predict the future. I didn't have to do price in 2020 to see the current value of this car. I could have put 2037, let's say. And if you plug in 2037, it will give you the price for 2037 for that car. Because, again, because it's old, right? It's getting older, but for some reason, right, the value is increasing, even though literally anything on the market in that given year is better than in performance and everything else than that car. Now let's take a look one more time at this same procedure, but with numbers that are far less complicated. So here is the problem. The problem says, and this is not applied problem, this is just what I call the boring problem. It just says, write the equation of the line going through, and now you get 2 points. -1, 2, and 6 and 3, whatever. The procedure is going to be step by step exactly the same as the word problem with the car. Everything is the same. You will label this as a 0.1, label this as a 0.2. You can do it the other way as well. And use that to compute slope. y2 minus y1 over x2 minus x1. Your y2 is 3, minus y1 is 2, divided by 6 minus -1. So this is the skill from last class, right? We learned this on Tuesday. 3 minus 1 is 2, 6 plus 1 is 7. Right, so now the slope is this easy 1 over 7, right? And earlier we had that 6,500 over 7, right? Now we have 1 over 7. It's just smaller numbers. But we did the same step. We still plugged in all four values from the 2 points we have, and we plug them in the particular order, which is governed by the formula that you memorize. And then we computed the slope. We also have that x is equal to -1 and y is equal to 2 from the first point. Once you plug all of those in y equal mx plus b, you have something to compute. Y is 2, m is 1 over 7, x is -1 plus b. When we multiply this fraction by -1, it just becomes a negative fraction. And to get b, right, the basic idea from your chapter 2 is to add 1 over 7 to both sides. That cancels 1 over 7 here, and you have that your b is equal to, you can call it 2 over 1 over 7 if you want to, right, as a mixed number. Some of you did ask about that at the first day, so here it is. Or you can write 15 over 7, right? 2 times 7 is 14 plus 1 is 15. Or you can say I have 2 whole units of all 7s. So I have 7 over 7 and another 7 over 7 and then 1/7 in addition. That's altogether 15. This is 1, this is 1, this is 1 over 7. 1 plus 1 is 2 and a 1/7. So we have these guys and then this one. So 14 plus 1 is 15. Some of you know the trick. To multiply these two numbers, you get 14, and then you add plus 1 gets you 15. So whatever way you know to convert from mixed numbers, whatever, we just need that 15 over 17 over 7 there. So now I can write that y is equal to, I have my slope of 1 over 7, x plus 15 over 7, and we're done. There it is, equation of the line in slope-intercept form. And graphing of this is not going to be fun, obviously, because 15 over 7, right? But that's almost 2. So it's not impossible. It just requires a little bit more, right, OCD to do that good. And let's have another example, but this time I want to pick up the example from the textbook. The way they ask to find they have 6 word problems. Oh, they have these ones as well. I did not okay, I didn't talk about that yet. Eesh. So problems 57 through 60 give you charts with 3 points, but you can pick any 2 points and then compute the values. So I'm going to give you 2 points from, let's say, problem 58. It doesn't matter. So use the 2 points from problem 58. Those points are -1, 4 and 0, 8. To write y equal mx plus b following the steps above. So it's the same procedure. Calculate slope m using the formula and then plug everything into y equal mx plus b and compute b. Let's see how that goes. And if you're done with the line, you can just tell me what you have. I can write it down.
What does the y go to in the y equals mx plus b?
Y is, well, depends which point you pick. So it's either going to be 4 or it's going to be 8, depending whether you're using first point for x and y or second point for x and y. It's going to be one of those two. Which point did you use? Did you use -1, 4 or 0, 8?
So I did. I only got to like where I got m, the slope is 4.
Okay.
And then I have just y equals, I did 4x plus 8.
Okay, so now you can proceed in two ways, right? I'll show the other one. So plug in x and a y if you want to do exactly the same way I did in the previous two examples. So pick one of the 2 points and plug in your x and a y. And then you will have b unknown. You can calculate b from there. Let's take a look at this problem together, and I'll show another trick when you have a point that has a 0 in here. But let's deal with the rest of the stuff. So we start always with the slope m. If you call this point 1, call this point 2. You have your 8 minus 4 divided by 0 minus negative 1, which is 4 over 1, which is 4. So this is your y2 minus y1. Here's your y2. Here's your y1. It's always the y is always the second coordinate in every point. And then you have your x2 minus x1. So that's your x2 and that's your x1, because x1 and y1 belong to the first point. Once we plug all of those in, right, this is the skill from the last class, we have our slope as 4. And now you can use either point 1 or point 2 to compute b. So if you choose point 1, you have more work, obviously, because look, point 2 has a 0 in it. It's much easier to compute with 0 around. So I'll do both, so we can see that they give the same answer. So if I use x equals negative 1, y equals 4, and m equals 4 in y equal mx plus b, then my y is 4, my m is 4, my x is negative 1 plus b. This is 4 equals negative 4 plus b. And when I add 4 to both sides, I get that b equals to 8. If I use the other point, I will get the same answer. It's just going to be way quicker. If I use x equals 0, y equals 8, and m equals to 4, y equal mx plus b, plug in y, that's 8, equals to m is 4, and look, times 0. You immediately get b is 8, because 4 times 0 is 0. It's gone. So you just have b is equal to 8. So we can now write that equation is y equal 4x plus 8. And we're done. So I did two separate ways using point number 1, using point number 2. They both gave us the same b, and they both started with the same m equal 4, right? So it is the same line, and obviously you have to get the same answer because, right, these 2 points are supposed to be on the line, which means they satisfy the line. If you plug those values into the equation, you're going to get the true mathematical statement. So they have to both work. And now you have the equation of the line. Now I want to show easier problem than this. Find equation of the line given slope is, let's say, -1/2 and y-intercept is, let's say, -2. I'm going to write this in block. Just plug in. There's nothing to calculate here because they just gave you that m is -1/2 and b is -2. It's given in a text. So you just plug them in and you're done. Now this b is equal to -2. If you paid attention earlier, you know that that is 0, -2. And I said, what is special about all of the points that have 0 first? They're always y-intercepts. And your formula has a y-intercept on a display. So that helps a lot in coming up and reducing the work when you are trying to compute these equations of the line. Now let's see. So graph the equation, we did all of that stuff. Write the equation, slope-intercept form, we did that. Here is the graph of the function, good. All right, write the equation given n and b, we just did that. So the only thing that is left, we also did the word problem just to show, right? And we did another 2 afterwards, right? To show that we can apply this very well and have some really good results. So these problems are rare in algebra. What's coming up now? So the last part of this is parallel and perpendicular lines. This is also in the same 3.5. It is just a subsection of it. And what it's all about is how to find the equation of the equation of your line, given that that line is parallel to another line. Now, you might say and ask, why is that important? And obviously, if you're not going to pursue physics or STEM field, it's not. But if you are pursuing physics or mathematics or any type of engineering, it's insanely important because we deal constantly with parallel and perpendicular lines, and we use them to create shapes. So rectangle is and parallelogram as well. Those are the shapes that you get with 2 sets of parallel lines. Whether you put parallel lines this way, meaning separation is the same, and you put two parallel lines this way, and you have a rectangle in between. If you put these two guys at an angle, you get what we call parallelogram. So these types of problems are insanely important, but they are important more for like STEM than in general. But anyway, they have problems 67 to 76 dealing with these types of problems in a book. So you might run into some of these on your homework. And again, if something is not clear, you can always go back YouTube video, right? And go back to the concept and watch it again and again, and then stop by office hours. Before we do any calculations, two lines are parallel if the separation between them is always the same. And you can think of train tracks. Train tracks are always the same separation, and as soon as they are not the same separation, the train derails. So two parallel lines have when we're talking about on a flat surface, obviously. So on the flat surface, two parallel lines are always equally spaced from each other. And what's more important for us, they have the same slope. So parallel lines have the same slope. If this is my line 1 and this is my line 2, we'll say that the slope of the first line is equal to the slope of the second line. That should not be hard to believe. If you take a look at the cross section of your house and you look at the floor and the ceiling, they are parallel, hopefully, right? Same separation everywhere, whether it's 8 feet or 10 feet or 12 feet, whatever, from the floor to the ceiling. You always have same separation everywhere. And both of those are horizontal. Your floor is horizontal and the ceiling is horizontal. So if they are perfectly flat, you put the marble on either one of them, they're not going to roll. And then the second one is the perpendicular when they are at 90 degrees. Perpendicular lines have slopes follow the negative reciprocal rule, m1 equals negative 1 over m2. So this is when they are at what we call 90 degrees angle. And this is the formula for the slope. So these are the two additional pieces for slope that we need to know in order to solve these problems that are at the end, right before your word problems kick in. So I'm going to solve one parallel and one perpendicular example, and I hope that you will practice these as much as possible to learn as much as possible. So problem 72 says, find the slope-intercept form of the line passing through point -3, 1 parallel to negative x minus 3y equals to 9. There we go. So this is information given. And as I said, in physics, engineering, and a lot of other areas, they're all STEM related, obviously. This stuff pops up and also pops up in terms of planes in calculus 3 and so on. So it gets to be upgraded. What do I have? What do I need? Well, they want y equal mx plus b form. And I need this one, and I need this one. I don't have any of them. However, if you understood the previous problems we did, and you realize that the word parallel and a line was given, parallel means same slopes. If I can extract the slope from here, that would be the actual slope we need. Because if the two lines are parallel, they have the same slope. It's like a detective work over here. So, all I need to do is to transform this into y equal mx plus b form, and then I can just read the slope, because it would be a number. And then I have a point, I have a slope, and I can calculate b. All right, one thing at a time. So let's go and figure out what is the slope given this equation. Negative x minus 3y equals to 9. We need y by itself, right? Y needs to be by itself. So we have to get rid of the rest of the stuff that is in its way. So plus x on both sides. And this is now the flashback, hopefully, to your section where you did those formulas when you were shoveling things around. It's exactly the reason why we learned that section, so this section can go smoothly. On the other side, we have x plus 9. And now divide both sides by negative 3. You can divide each one individually by negative 3. Tends to be easier that way. And when the negative 3 cancels, you get y equals negative 1/3 times x minus 9 divided by 3 is 3. Positive divided by negative is negative. There it is. We have our slope, negative 1/3. We also have a point, negative 3, 1. So we can feed all of that into y equal mx plus b and calculate b. Y is 1, m is negative 1/3, x is negative 3, oh that's convenient, plus b. 3 and 3 will cancel, negative and negative make a positive. Nice. So b is 0, right? Because 1 is equal to 1, b must be 0. So b is 0. Or you can say minus 1 both sides, whatever. So now we know what the formula is. Y equals negative 1/3 x plus 0, but we're not going to write plus 0 because there is no reason to write plus 0. And there is the equation. So this equation is parallel to the line they gave us, and it's going through the point negative 3, 1. So the new component here was using the skill from before to flip the formula around so we can see what m is, because in this form, once we put this in this form, this number is m, this number is b. Now this is the old line, right? And this is the new line. They both have the same slope because they are parallel. There are two parallel lines, they have the same slope, but they have different b values, obviously, because they are apart from each other. That's a parallel problem. Perpendicular is the same thing.
What? Real fast.
Uh-huh.
How did you get 0 though for B? Where did that? I don't understand where that came from.
From here, you solve the equation.
But I understand that 1 equals 1 plus B, but then how does B become 0?
Well, what value do you add to 1 to get 1?
Okay, that makes sense.
All right, cool.
Now I see it.
All right, cool. Or you can say -1 both sides. I mean, whatever makes you happy.
Yep, that makes sense
Right?
now.
Your happiness is our primary concern over here. Just like United Airlines, right? Just don't cross the line. I think that meme is now too old. I have to come up with something else. I don't know. Let's take a look at perpendicular problem. And we can just jump right to 73, the next one. Doesn't matter. It's the same text, except this is perpendicular and this is a different problem. This is the different thing, right? So let's go and say, find the slope-intercept form. Find the slope-intercept form of the line passing through they have 0, 0. Wow, this is going to be a very quick calculation. Perpendicular to they even give us the easy equation. Oh, wow. 3/4 x minus 1/2. All right.
Hold on.
Same.
Hold on.
It is the same procedure, except now we have to use the perpendicular slope, and for perpendicular slopes, we have this equation here. Now, between M1 and M2, the relationship is you flip the fraction and change the sign. I'm actually going to write that here as a flip the fraction and change the sign. That's the fastest way to remember what this formula does, because literally you will come up with from here you will say M1 is equal to 3/4. M2 is going to be -4/3. That's what we have. So this is the slope that we need. This is the slope that we have. The top one is the slope that is given in the line that we don't want. We want the perpendicular line. So this line here is some line somewhere. We are supposed to construct perpendicular line that will have a 0, 0 somewhere on it. So the 3/4 slope is on the line we don't want. Our slope is -4/3. And you can see that our slope is a negative slope. It goes down, right? And it's 90 degrees to the other slope. So the equation that is slope is given is a base, and then for perpendicular slope, you flip the fraction and you change the sign. So now we have the slope and we have the point. Y equal mx plus b with a slope of -4/3 and x equals 0, y equals 0. We got to plug all of those in. So y 0, m is -4/3, x is 0, and then plus b. So from this calculation, we come up, when you multiply by 0, right, it's 0. So it's just 0 equals b. Again, we got b equals 0. Yeah, whatever. So our equation is y equals negative 4/3 x plus 0. So it's just this. And that solves the problem. It is a very structured procedure. You always, for all of these equations that we did, so we go way back, including the word problem with money and a car. All of these problems had the same shell, meaning same steps. Get the slope one way or the other, either using the slope formula, using the parallel or perpendicular method, or the slope might be given. We had the problem where the slope was just given in the text. See this one? If the slope is negative 1/2, oh great, I don't even have to think about it, it's given. So your problems break down into what type of information I have to figure out the slope. So it can be, you have 2 points, so you can use the formula y2 minus y1 over x2 minus x1. So if you have 2 points, you can use the formula. If you have parallel, you keep the same slope. Perpendicular, you have to flip the fraction and change the sign. And the slope also could be just given to you, like this. And then you just get to plug it into the formula immediately. So you can have any of these, and when you come up with the problem, you only need to compute b. You use the point, you compute b, and that ends the whole story of slopes, and also ends chapter 3. So now, if we put the entire chapter 3 together and think what chapter 3 was all about, it is about x and y coordinate system with the origin in the middle. It is about graphing the points, graphing the lines. It is about understanding that those lines can represent the values which we can use to compute things like, money and depreciation in price or something. It is a lot of stuff that is very, very useful. We can use it to calculate even interest rates, figure out the future payments, figure out the value of things that either depreciate in price, meaning the price is diminishing over, the value is diminishing over time. Or we can look at, maybe population. If its population is never linear, we usually have exponential models for population, but we can, approximate on a short run with a linear line as well. We learned about the slope. We learned how the whole thing goes up and down, and when slope rises to the right is a positive slope, and falls to the right. When the line falls to the right, the slope is negative. We learned a relationship between two lines. Parallel lines have the same slope. Perpendicular lines, we flip and change the sign. And at the end, we learned that we can graph the functions, graph those lines. If it's a standard form, we use the x and y intercept with a chart. And if it's a y equal mx plus b, we just use the counting method where we graph the y-intercept, and then we graph the y-intercept, and then we do the counting for the slope as rise over run. And that completes chapter 3. We will have to move for the next class, our chapter 4, obviously, because we only have a few minutes left. We cannot go through 4.1, but I can at least set up 4.1 and tell you that you must learn graphing well, and you really need graphing paper for the next class. Those are the two, because the next class we are going to take a look at the coordinate system like this, and we're going to graph 2 points, 2 lines, and then read off of the graph where this intersection is. In my case, 1, and then maybe 1.2 over here. Just whatever, right? So the graphs need to be perfect, the 2 lines, and then we will always be graphing 2 lines onto the same coordinate system and look if they intersect or not. If the lines are parallel, they do not intersect, so we will have no solution. You need graphing paper, you need a straight edge to complete 4.1, because if you don't have them, you are not going to draw straight, right? If you do something like this, where it's nothing is straight, you have different divisions on x and a y, and then you connect your x and y intercept, and then you have the other line. This point here, does it really fall where it should? It's not going to, because the distance here and the distance here and the distance here are not the same. And you can see distance here is different and so on. So I have seen, fair share of horrors throughout grading these exams. So we are going to, if you are interested in obviously scoring well for 4.1, you need graph paper, which you can either pick up at the store, or the easiest way obviously is to print few sheets off of the, just type in Google or Bing. I don't know, maybe you're a Bing person. So Bing graph paper, and it will come up as images, and just print out few of those. And for the straight edge, you can literally use anything that is straight. I mean, dollar store triangle, right, would work, but maybe you have them laying around the house. I don't know. Probably not. I mean, education is so devastatingly terrible today that, it's very difficult to find a triangle straight edge, right, in a house laying randomly around. It's been generations of absolute nightmare in education. So, but you can use the hardcover of a book or a notebook or a box or something as a straight edge. You absolutely need to have those lines perfectly straight, and you need the grid that has even divisions on vertical and horizontal axis, so you can have the graph straight. And you will see all of that obviously next class. So with that, do you have any questions, anything before we end today? The awkward silence. I guess that would be a no. All right, then I will see you all on Tuesday, or if you join office hours before the class. Bye.